Okay, this is chapter 2, day 2 of AP statistics, and this is the empirical rule. All of this is estimation, so you're not going to need a calculator today. And as always, you should stop the video and check things out and write things down as you need to. It's not a super long lesson. The empirical rule is better known as the 68, 95, 99.7 rule. And it's for really nice z-scores of a z-score of 0, 1, 2, 3, or -1, -2, -3. Z-scores above the mean or positive, below the mean or negative. So not all data is normal, but many things are normal. Things that are normal are like heights and shoe sizes in societies are typically normally distributed. Things that are not normal are like income. There's income is skewed to the right. There's very few rich people and most people make a modest income. They're on the left. So not all data is normal, but a lot of it is. And we study normal curves extensively in this class because there are techniques to normalize data with sampling distributions. That's coming in chapter later on. I think it's chapter 7. So it'll play out there. But for right now, let's study the 68, 95, 99.7 rule. And this is an area thing. So as you probably realize, the area in a normal curve is 1. And 68% of the data is within 1 standard deviation. So the area between -1 and 1 standard deviation is 68%. It's about that. I think it's 0.6815 technically, but these are estimates. 2 standard deviations away is about 95% of the data, and 3 standard deviations away on each side is 99.7, almost all of the data. So for you calculus geeks, there's an inflection point right here at the first standard deviation on each side, and the curve actually gets slightly steeper at that point. You don't need to know that. This is a non-calculus based class, but just in case you were curious about that. Okay, so to break it down, this is really the one that's pretty important to know. Okay, so that's the key one. So 34% between a z-score of 0 and -1, between 0 and 1 is also 34%, etc. So if you notice, this is 68%, all of this is 95, but these are the areas of this. It's really kind of handy to have a handle on this. Okay, really what this is for is estimation to keep you out of trouble. And the AP test, you're allowed to put approximate answers anyways. So if you have a z-score of 1, for example, the percentile rank is actually 84%. It's 0.84 because here all the way down is 84%. Within 1 on each side is 68, but all the way down is 84. So you sort of have to keep that straight as well. Okay. Okay, so let's walk through this again. This is a non-calculator deal here on this. Let me move this up a little bit. Okay, I'll leave that drawing. That drawing is really, really helpful. Okay, so find the percentile rank for the number 48. If you see, you only need 2 numbers to describe a normal curve. You need the mean, that's the first number, and you need the standard deviation, that's the second number. The n in front of the parentheses means normal curve. So that's standard notation for a normal curve. Okay, so if you have a z-score, x is 48 with a mean of 50, you can tell that that's 1 standard deviation below the mean, 1 set of 2 below the mean. So the z-score is -1. And if your z-score is -1, you're right here. And this all the way down is approximately 16%, okay? You can add all those up, or you can remember that 68% is within 1. That leaves 16% for the top and 16% for the bottom since it's symmetric, okay? The next one, item C here, normal curve, mean 38, standard deviation 3. 44 is 2 standard deviations above the mean. So that's right here. 2 standard deviations above the mean is right there, okay? And what that means is, if remember, 95% is within 2. So if that's 95% within 2, then 2.5% is down here and 2.5% is up here, because 95 is within 2. So here all the way down would be 95% plus 2.5%, approximately 97th or 98th percentile. Okay. Generally, you don't put a decimal for a percentile, you round it to the nearest whole number. Okay, the next one, you can read this for yourself, but this has a z-score of 3. There are 3, if you add 0.4 to 92.1 3 times, you'll get 93.3. That's a z-score of 3. And that puts this z-score of 3 is way down here. That's about the 99th percentile, okay? Because here all the way down is over 99%. Okay? So similar questions coming up here on E. What percent is less than 9? So 9 has a z-score of -2. If you subtract 12 minus 1.5 twice, you'll get 9. That's a z-score of 2. So z-score of 2 is down here. The percentage that is less than that is 2.5%. Remember, within 2 is 95%. That leaves 2.5% here and 2.5% down here. So less than that, 2.5%. Okay? And 1F, what percent of the data is greater than 230? Greater than 230. If you go 320 minus 33 times, you'll get 230. That's a z-score of -3. That is way down here. Okay? And as you can see by the chart, greater than that's going to be all the way this way. That's about 99.85%. Item G, if n is 245, the mean's 245, standard deviation is 15. What percent is greater than 260? Okay, is greater than 260. I actually have the wrong answer here. Greater than 260. 260 is a z-score of 1. That's right here. The area above that is 16%. The area below that would be 84. I had the wrong answer there. So that's 16%. All right, H. Slide this up slightly. There we go. So actually, I'll make it just a little bit smaller so we can get it all in here. Perfect. Okay, so I'm on H. So again, mean is 10, standard deviation is 0.7. What percent fall between 9.3 and 10.7? Well, 9.3 is a z-score of -1. That's right here. And 10.7 is a z-score of +1. That's right here. And we know between 1 and -1 is 68%. That one's pretty easy. Next one, I, a normal curve, mean 70, standard deviation 3. What percent fall between 64 and 76? Well, 64 is a z-score of -2 down here. Then how you do that, if you remember from the other day, I haven't been doing this because of yesterday's lesson, but it would be 64 minus 70 divided by 3. And that comes out to be -2 right here. And then 76 is 76 minus 70 divided by 3. And that's right there. Okay. So between 2 and -2, that's right here. That's 95%. All right. And then J, mean of 11, standard deviation 0.5. What percent of data fall between 9.5 and 12.5? Again, if you do the math on it, you go 9.5 minus 11 divided by 0.5, and that comes out -3. And then on the other one, you go 12.5 minus 11 divided by 3. Divided by 0.5. And that comes out +3. So between 3 and -3, I'm drawing this between here and here, 3 and -3 is 99.7% of the data. So these 3 are simply a reflection of the empirical rule that was taught at the very beginning of the lesson. Now the next ones get a little harder. Okay, they're not much harder, but they get a little bit harder. All right, so the next one you got right here, mean of 45, standard deviation of 4. What percent fall between 37 and 49? All right, so 37 minus 45 divided by 4 comes out -2 right there. And then 49 minus 45 divided by 4 is +1. So you're talking between -2 and 1, okay? So it's pretty easy. You can add those 3 sections to it, okay? Some people will go 95% minus 13.5, which is fine. Some will go 34 plus 34 plus 13.5 and get 81.5. Either way, most people with a test like this, they'll actually draw this out on a scratch piece of paper real quick on a test so that they kind of have they can do the estimation real quick. So I recommend on a scratch piece of paper, you write this out as soon as you get the test when we assess you for this chapter. All right, L. Okay, mean is 180, standard deviation of 5. What percent fall between 175 and 195? I'm not going to do the math this time, but 175 is a z-score of -1. That's right here. 195 is a z-score of 3. Okay, so you got a couple choices, but you could just simply add all the areas. This area plus this area plus this area plus this. There's other ways to do it, but it comes out about 83.85%, something like that. Okay. And then the last one on this section is M. Normal curve, mean of 86, standard deviation of 7. What percent fall between 100 and 107? Well, 100 is a z-score of 2, and 107 is a z-score of 3. And as you can see, that's going to be 2.35%. And let's see here, 100 to 107. So this answer is actually wrong on the notes. So it's basically 2.35%. Caught a few mistakes there, no problem. Okay. Now the last one here, checks for normality. This is going to play out later in the course. We're just introducing it here. And this actually becomes kind of a big deal later. Okay, so it's good to see it several times. What happens is when we do mathematical proofs or statistical tests, starting in chapters 8 through 12, one of the requirements we have to do is we have to show that our data is approximately normal. And the reason we have to show that it's normal is because we're using normal calculations to prove something. So if something isn't normal, you can't use normal calculations. That sounds really simple, but that's how it works. There's actually 4 ways to prove something's normal, okay? Item 1 is you can the normal density curve or probability plot. It's been introduced before, but I'll introduce it again. The normal plot is basically what'll happen is you'll have a line here that's like a 0 line, and you'll have little tick marks for the z-scores, 1, 2, and 3 above, and 1, 2, and 3 below for the 3 standard deviations. And you'll have these dots. Typically, you don't make it, it's provided for you. And if the curve lines up more or less in a linear fashion, and it's one of those checks where you're looking for 68% of the dots within 1 standard deviation of the mean, 95% within 2, and 99% within 3. It's kind of a visual check. Now, we're not doing that here, so I'm just kind of introducing it, and that might be a little bit over your head, but that is a check for that. And we will go over that in more detail as we get closer to doing statistical proofs, okay? Second one's a real common one. It's when the box plot appears normal. All right, what is a normal box plot? This box plot is the most normal, okay? What you want is it to be symmetric, of course. This one is not symmetric at all. You want it to be symmetric because the normal curve is symmetric. And the box plot that goes with the normal curve, these leaves right here, these, I'm sorry, these whiskers, this is the box part, these whiskers off the box, they're a little bit longer than this part. So this length and this length are slightly shorter than this for a normal curve, okay? Now, if I saw this when I took data and graphed it, I would accept that as close enough to normal, okay? So another check for normality is the empirical rule itself. It's kind of difficult, but you'd have to go through, like let's say you had a set of 20 items, okay? So if you had 20 items, and then you got the mean and standard deviation, if you counted like 14 of the items, that's like 70%. That's pretty close to 68%. If you counted 14 of the 20 items within 1 standard deviation, that'd be great. And then if you had like 18 of the items within 2 standard deviations, and then if all 20 were within 3, it would basically fit the 68, 95, 99.7 rule. It's very bulky to do that. This is not common. This is common, and this is common, okay? And the other one is sufficient sample size. I put a star by it because I'm introducing a sampling distribution. So if you graph averages of greater than 30 consistently, and we'll do this in chapter 8, I think it's chapter 7 or 8, okay? If you graph averages of at least 30, the data will be normal. There's a really cool proof on that, a really cool app I'll show you on that. We're not doing that here right now, but it is available. So this will come up a lot. It's not a big deal right now, but I'm introducing it. Okay, so 2A, rank from least to most normal. The least normal is 1. They're in order. The least normal is 1, second here, and this is the most normal, and I already explained that. Okay, 2B is based on only this information that you got. Could you say that the data is normal? Okay, so if the mean is 18 of some distribution and the standard deviation is 4, and you scored a 26, and that's the 97th percentile, could the data be normal? All right, so what you would do is quickly calculate a z-score for 26. That z-score is 2. That I have circled right there. The z-score is 2, okay? And you think, so let me slide back up here real quick. So if a z-score is 2, then you're basically right about here. A z-score is 2. Yeah, if a z-score is 2, that's about the 97th percentile, 97th, 98th. So if that's the only information that you had, then yeah, you'd be able to say it could be normal. I don't think it proves it's normal, but it could be normal based on that's all you have, okay? 2C. So here is 2C. If the mean is 29.7 and the standard deviation is 2.8 and a score of 26.9 is at the 34th percentile, could that be normal? All right, let's check it out. So if you do the math and you go 26.9 minus 29.7, I'm doing a z-score, divided by 2.8, okay? That z-score is -1. And if you don't remember, a z-score of -1 is at the 16th percentile, okay? This says this is at the 34th percentile. So you would say pretty confidently this data in all likelihood is not normal, okay? And now the last one, if you have a mean of 22 and a standard deviation 6.5, a score of 28.5 to 68th percentile, let's see if that's about normal. Okay, so let's go 28.5 minus 22 divided by 6.5. Okay, so if you do that, that's a z-score of 1. A z-score of 1 should be the 84th percentile, and this is really odd. Okay, this says the 68th percentile, so no, definitely not. This is off. This is pretty far off. okay? And again, to show you that a z-score of 1 should be the 84th percentile, let me slide back up real quick, okay? And if you see this, a z-score of 1 is right here, okay? So this behind it is 84% if it's normal. And this prompt says it's a 68th percentile. So no, in all likelihood, you do not have normal data. Okay, that is chapter 2, day 2.